Welcome to this explainer. Today, we're demystifying the high-stakes how-to of AI risk treatment and corrective action under the ISO/IEC 42001-2023 standard. We're going to look at exactly how organizations can systematically protect their operations, their customers, and their reputations when deploying really complex artificial intelligence. Let's just dive right into it. When an AI makes a catastrophic mistake, who's responsible? And more importantly, how do we fix it? Managing AI risk is basically a mix of proactive health management and reactive forensic science. When algorithms are out there in the real world, making medical diagnoses, approving loans, or driving cars, the stakes are incredibly high. The ISO standard gives us a precise framework to ensure that when a system strays from its operational boundaries, we know exactly who is responsible and the specific steps required to correct it.
To keep us perfectly on track, here's our roadmap. We'll cover assessing AI system risks, choosing treatment strategies, implementing those plans, investigating failures, and finally, taking effective corrective actions.
Okay, part 1, assessing AI system risks, or what we like to call the triage phase.
Think about it like this. Before you can treat a patient, you've got to assess the risks, right? You literally can't fix what you haven't diagnosed. ISO/IAC 42001-2023 leans heavily on this concept of risk-based thinking. This means we have to anticipate issues like incomplete training data, algorithmic bias, or just totally unpredictable model behavior super early in the life cycle. It's a huge shift from just waiting for things to break to actively hunting for the uncertainties that could mess up our goals.
So, by systematically plotting the likelihood of a risk against its potential severity, we end up with a triage matrix. Take a biased HR algorithm, for example. That carries a high likelihood and a high severity, meaning it absolutely demands urgent critical care. But compare that to, say, a minor UI glitch, which falls right into our acceptable risk threshold. You have to do this prioritization before you even think about selecting treatments. Moving on to part 2, choosing risk treatment strategies. Basically, selecting the medicine.
Now that we've diagnosed the risks and ranked them, we enter the treatment phase. This is where we systematically select our medicine. And hey, not every risk gets the same prescription. There's a really fascinating contrast here between actively fixing a system versus shifting the financial liability to a third party. Mitigation is hands-on. You're actually altering the AI or its environment to reduce the danger. Transfer, on the other hand, is a strategic financial move. It's recognizing that some risks, like a highly sophisticated cyber attack, might just bypass your defenses anyway, so you buy cyber insurance or outsource data storage. The absolutely crucial takeaway here is that you have 4 distinct ISO-approved choices when an AI risk crosses that acceptable threshold. You can avoid it entirely, mitigate the damage, transfer the burden, or accept it if the cost of fixing it is just way higher than the potential harm. And remember, this systematic selection process must be rigorously documented. If an auditor comes knocking, you need to prove you didn't just guess, you strategized.
Which brings us to part 3, implementing risk treatment plans. Time for surgery.
Having picked our strategy, we now have to prep for surgery by implementing a highly structured plan. Identifying the treatment is only half the battle, right? Executing it properly is where so many organizations actually fail. You literally cannot just wing it. The standard requires a documented blueprint. A risk treatment plan, or RTP, aligns directly with your broader business objectives. If an auditor walks into your office tomorrow, this is exactly the document they'll ask for to verify you've translated your risk strategy into actual, measurable operational changes. When we execute this treatment plan, we can apply 3 distinct types of controls: technical, procedural, and organizational. This really proves that technical fixes have to work hand in hand with human oversight. I mean, you might have the absolute best explainable AI framework in the world, but without procedural controls like regular audits and organizational controls like an ethics board to review the findings, your technical tools are basically operating in a vacuum.
If there's one thing you should take away from this entire section, it's that clear accountability and proper documentation are what make these controls legally defensible. The treatment plan must clearly identify the responsible individuals. For example, if an AI loan system relies on biased data and starts unfairly denying applicants, an ISO-compliant system lets you trace that decision back through a clear audit trail directly to the original parameters set by the design team.
All right, on to part 4, investigating AI system failures, the forensic investigation. But what happens when the preventative medicine fails and the AI actually causes harm? Despite our absolute best efforts, models drift, new adversarial attacks pop up, and data gets contaminated. That's when we have to put on our detective hats. When an incident occurs, we have to move past the immediate symptoms to discover the true systemic disease inside the AI model. ISO/ISO 42001 mandates that organizations don't just slap a Band-Aid on a problem. No, they must perform and thoroughly document a formal root cause analysis. Let's look at this workflow. By continuously asking why, we trace the issue all the way back from the incident to the original systemic flaw. Maybe the AI made a biased decision. Why? Because the training data was skewed. Well, why? Because the data collection process ignored a specific demographic. Why? Because the collection policy was completely outdated. Boom. By digging down, we find the exact procedural failure we need to fix. Here's a great case study showing that an AI failure isn't always some rogue algorithm acting on its own. A lot of times, it's literally just a human procedural error. In this instance, phishing emails bypass security. But the failure of the automated filters wasn't some deep neural network mystery. It was just a failure of the IT department to track and apply software updates. Good forensics reveals the truth.
Finally, Part 5, Taking Effective Corrective Actions. Let's talk about the cure. Once our forensic investigation uncovers that root cause, we have to apply a permanent cure. This is where we close the loop and make absolutely sure the failure never happens again. Let me tell you, vague promises simply won't survive an ISO audit. Saying, "we'll try to do better next time," is definitely not a corrective action. Your corrective actions must be strictly defined, properly resourced, and rigorously executed according to SMART principles: specific, measurable, achievable, relevant, and time-bound.
A fully compliant corrective action plan has to document every single one of these elements so nothing slips through the cracks. It is never enough to just deploy a fix. You have to rigorously document what broke, why it broke, who is responsible for fixing it, when it will be fixed, and, perhaps most importantly, how you will actually verify that the fix worked months down the line.
The big takeaway here is that the cure has to directly target the exact disease we found during our autopsy. For instance, if the root cause of a recruitment AI failing was biased historical hiring data, the specific corrective action is to reweight that training data to balance the scales. Then you'd add an explainable AI layer so human auditors can easily verify the logic of future candidate recommendations.
Looking at this timeline, it becomes super clear that treating AI risk isn't just a one-and-done task. It's an endless cycle of continuous monitoring and improvement. Implementing the corrective action in month 3 isn't the finish line. The ISO standard explicitly requires follow-up audits, like the one shown here in month 6, just to verify the effectiveness of the action. This is the classic plan, do, check, act cycle right in motion.
I want to leave you with a final, somewhat provocative thought to ponder as you build your own frameworks for the future of AI. Implementing risk treatments and doing root cause analysis on regular, static software is one thing, but doing it on an autonomous system that continuously learns and evolves its own behavior over time, that is the ultimate test of your governance. Thank you so much for joining me for this explainer, and good luck building your AI management systems.